Hello and welcome to this session. So in this session we're going to be looking at examining best network practices, and this is basically the procedures that one is supposed to follow when you're in an environment, you're in a networking environment, or as a network engineer, a systems administrator, and other roles that come with the networks. So if you're into this kind of content, remember to hit the like button, comment on the comment section below, and also subscribe to my channel so that you're updated each time I upload a new video. And if you have any comments, write them down on the comment section. I'll be ready to reply to your comments or critics. Okay, let's get into it. Now let us first look at some of the safety procedures that we need to follow when it comes to our network environment. You have what we call as a power safety. And power safety means that you have to be secure when you're working with these networking devices. For example, one, you're supposed to remove power before working on a certain device. Okay, do not work on a device when it's plugged in. Two, make sure you're wearing a wrist strap when working on any equipment. A wrist strap is what removes the electrical charges from your body. Remember, your body is able to carry the electrical charges, and whenever you're tampering with these devices, the electrical charges on your body might interact with whatever charges are on the device, and they could damage it. So that's why you need to wear a wrist strap when working on any equipment, and that wrist strap should have a resistor, meaning that it's able to cut the charges when it comes to the electrical charges on your body or on that specific device. Let us look at safety number 2, that is lifting safety. Now, some of these networking equipment that we talk about, for example, some routers, some switches, some servers could be very heavy. So get assistance when you're lifting some of these networking equipment. This ensures that one, the equipment is safe. Two, you're not harming your body by trying to lift a very heavy equipment. If you're in a data center, make sure you're using forklifts to lift this kind of equipment. Another safety procedure when it comes to lifting safety, you're supposed to put the heavy equipment at the bottom of the rack. For example, a server might be very heavy compared to a router or a switch, so make sure that your servers are below or at the bottom of your rack when it comes to network or data centers. And the equipment that is on top or up or at the top of your rack should be the easiest or the not so heavy equipment. Okay, let us talk about another safety, and this is fire safety. Remember, in networking, you're supposed to use gases, not water, when you're suppressing fires. When it comes to fires caused by this networking equipment, use gases, not water, because if you use water, then you're just going to accelerate the fire. So kindly use gases. Number 2, when a fire happens in your area of working where you have networking equipment, make sure you exit the room. Okay, and after exiting the room, make sure that the heating, ventilating, air conditioning systems are also off, so that you don't propel the fire to move to other areas of the building where it has not yet reached. We talked about HVAC systems when we were talking about our what were we talking about? But I talked about HVAC systems in an earlier video. I'll make sure to link the video in the description below. Now let us look at another type of management, and this time we're going to be talking about wiring management. Let us first define sometimes when it comes to wiring management is what we call as an IDF, an intermediate distribution frame. And this is a common location within a building in which cables from nearby offices terminate. Okay, and we have another one known as the main distribution frame, or the MDF. and this is the centralized wiring location within a building that connects out to IDFs, or the intermediate distribution frames within that building. So you could have different IDFs that connects different offices, and then you have the main distribution center, or the main distribution frame, which serves the different IDFs. Some of the things that you're going to come across when you're doing wiring is what we call as the one-time block, the patch panel. I talked about the wiring components in a separate video. I'll make sure to link it in the description. And those are some of the things you need to know. Another time you need to remind yourself regularly is the minimum bend radius, and this comes in when you're using fiber cables. And what minimum bend radius just means is just the minimum distance from the center of a coil of a fiber optic cable. Note, if the fiber optic cable is coiled too tightly, then you may experience signal loss, and this could be due to breakage and those kinds of things. So whenever you are dealing with fiber optic cables, make sure that the minimum bend radius is maintained. Another management practice that we do when we are wiring is using a plenum cabling. Okay, and what I mean by plenum cabling is a cabling with an outer insulation, so that if fire catches that specific building, it's not going to get to the wires. Okay, so you have all your wires in a plenum cable, and this basically protects all your cables when it comes to raised floors and open air ducts. Okay, so if you need to go up, you need to put all your wires in a plenum cabling, so that in case of a fire, first the network equipment will not be touched. Now, and this is a very common problem when it comes to engineers: spaghetti wiring. Network engineers, and not all of them, but most of them are very careless when it comes to wiring. You have cables running all over. Okay, make sure you use a correct cable length. Okay, avoid spaghetti cabling. I hate spaghetti cabling. I remember that one time I got very verbal with someone who was doing this spaghetti cabling, and he was not willing to accept that he's doing a wrong job. But if you try to explain it to him, he's very anyway, let's leave that alone. But use correct cable lengths, use cable management systems, separate electrical and networking cables. Do not put them together. That should be common knowledge. And then make sure you label both ends of the cable. If a cable is coming from a switch and it's coming from port 1, make sure you label it port 1. If it's going to the computer room, or wherever you place your computers, or to any other room, make sure you label that this wire comes from here, from up to here. And this helps you in management when you're doing repairs. It might not seem a lot when you're putting it up, and it's going to be a lot of work when you're trying to do cable management to avoid the spaghetti wiring. But trust me, it helps a lot, and this should just be OCD for when it comes to network engineers. Please, please, please avoid spaghetti wiring. Let us look at another management practice that we need to look at when we are dealing with our networks, and that is power management. How do you ensure that you are continuously connected to power in case of a power outage? There's what we call as the uninterruptible power supply, and these vary in sizes. Okay, UPSs vary in sizes according to your needs, and a UPS helps a device to run temporarily so that you can correctly shut it off. Or now, There's what we call a UPS, and a UPS helps you to run the device temporarily until either you switch to another powered device that is able to supply power to your equipment, or you're able to shut off that device correctly before the UPS runs out of power. So it's basically a notification that helps you to avoid data loss by these power outages and such kind of issues. There's what we call as a standby power supply, and this is what I was talking about. And this is a device that can temporarily provide power to a device in the event of a power outage. And this could be a generator. Okay, so if power goes off, make sure you have a standby power supply in your premises to ensure that you have continuity of your day-to-day activities in the network. And the generator is the most common, and they come in different sizes, so you're just going to choose that the one that suits your specific needs, or your specific networking needs. There's what we call as a power distribution unit, and a power distribution unit is able to pull power from different power sources. Let's say from your main power source, that could be the power company in your country, and then the generator. Okay, so it's able to pull device power from both devices, that is your power supply and your generator, to ensure that if one part fails, it could be your power supply or your generator fails, then you have overfill services. It's able to provide a redundant power supply to your specific devices. Now, another thing you need to note when it comes to power is you need to provide or supply proper power to your devices. There are those devices that need AC, that is alternating current, and there are those devices that need DC, that is direct current. So make sure you look at the specifications of your device whenever you want to supply power to a certain device. Let us look at another type of management, and this is rack management. Okay, and for different rack options, the main option that we have is the 19-inch rack. That is a 2-post rack for a small equipment, and a 4-post rack for a large equipment. Ensure that you are installing rails and lock up the rack. Rails help you to pull out devices out of your rack and to put them back when you're done servicing them. And also make sure you lock up your rack just as another layer of security when it comes to your network devices. Now, there's what we call as cold ISOs and hot ISOs, and what I mean by ISO is just a spare equipment that you have. It could be location and equipment, or just equipment. And cold ISOs means that you have the location and equipment. It's not running, but it's there, readily available in case of a catastrophe or failure of one location or equipment in one location. So that is what we call as a cold ISO. A hot ISO means that the equipment and the location are up and running, so that if you have failure on one side, then you're able to easily shift to the other equipment and location that you have. Let us look at another type of management, that is change management. And as we all say, change is necessary, and without change then we cannot have progress. So in case of change, change introduces new users, so you need to make sure that your team is aware of other changes or changes within your network, and this helps you to ensure that you have high availability. Okay, so changes do not bring about problems when you're working within your systems. Now, talking of availability, there is the term used that is the 5 nines, which means 99.9999% uptime, which translates to 5 minutes down per year, and this is what is recommended for most systems. But when you're talking about availability, availability comes at a higher cost, and this means that you're going to have redundant components, maybe routers, switches, servers, you name them, UPSs, generators. You need to provide all that so that you are able to provide your availability. Ensure that you deploy fast hop redundancy protocol routers in your network so that you can achieve this availability. Now, when I'm talking about availability, what you need to another term that we need to define is fault tolerance. And this is the ability of a device to continue operating if one of its components fail. Fault tolerance, redundancy. These words can be used interchangeably according to whatever you want to refer to, but they can be used interchangeably. So offering more redundancy may also bring a lot of complexity when it comes to your networks, and this comes in terms of configuration, maintenance, and making sure that all these redundant components are working flawlessly. Now, another way that you could provide higher availability is by having multiple ISPs, have more than one internet service provider. This increases your throughput and provides redundancy. So if you have one ISP, it will be kind of cumbersome when the ISP is unable to offer certain services at a certain period of time, either due to failure in their systems or their networks also. So the need to have two ISPs comes in so that you're able to increase your throughput and provide redundancy instead in case of a failure. Another strategy you could do to increase availability of your systems is by NIC teaming, network interface card teaming between servers and switches. This creates a virtual network adapter made up of physical network adapters. So you're able to merge your network interface cards between your servers and switches to provide a higher throughput or load balancing between different servers and switches. There's what we call as port aggregation. This is whereby, remember when we were learning about switches, we talked about port aggregation. Port aggregation is whereby you logically bundle multiple switch ports into one logical interface. Okay, so different interfaces or different ports in a switch, you bundle them together to make one interface that is able to provide load balancing. It's able to help you separate network traffic, but redundancy is more common, because if one port fails, that means the other ports that are bundled in the same logical interface are going to provide gateways or paths in which you can use to communicate. Now, we have been talking about the load balancing for a long time, and I think we need to define load balancing. And load balancing just refers to reducing a server load. Take, for example, you have one server providing services to 50 users, and another company has 50 servers serving 50 users. Which one is going to be more faster? Of course, it's going to be the one with 50 servers. Why? Because the servers, the time taken by one server to serve 50 requests at one time will be way much than whatever time will be taken by the 50 servers to serve the 50 customers, since it's going to be either one request per server or two requests per server according to the response time. Now, talking about availability, people have now moved from their local machines to the cloud, and in the cloud we can achieve a high availability by deploying virtual security appliances like virtual firewalls and virtual servers, all that appliances, having redundant VMs or containers. Those who are aware of Docker is able to hold several operating systems for you, and Kubernetes is able to manage these Docker containers, a lot of Docker containers at once. So if you can deploy these redundant VMs using Docker or Kubernetes technology, then you're able to provide high cloud availability. And cloud availability also depends on data center tiers. We have different data center tiers. This tier 1, this tier 2, this tier 3, and tier 4. What I mean by tier 1 is that you have either little or no redundancy. And the availability is at 99.671%. That means that you are down 28.8 hours annually. Okay. Tier 2 means that you have incomplete redundancy. Yes, it's there, but it's incomplete. The percentage of availability is at 99.741, and you are 22 hours down annually or per year. There's what we call as tier 3 data centers. These have redundant heating, ventilating, and air conditioning systems and other components. They are redundant, and the availability percent of tier 3 data centers is at 99.982%. This means that the data center at tier 3 is 6 hours down annually. Okay. Now, we are talking about tier 4 data centers. These data centers are built to be completely fault tolerant. That is redundancy for each device. If it's a router, if it's a switch, if it's the HVAC systems, all the devices have a redundancy. And the percentage of availability when it comes to tier 4 data centers is 99.995, which translates to 26.3 minutes down annually. So according to your financial resources, choose an appropriate data center tier to run, so that you're able to provide a higher availability. Now, let us look at the first hop redundancy protocols. We talked about first hop redundancy protocols earlier, and what a first hop redundancy protocol means is that it's able to provide redundancy to a subnet's default gateway. That is, in case a default gateway or a router in a certain network fails, then you're able to get another gateway to take you out to the public internet. And in these first hop redundancy protocols, we have two types of links. There's what we call as active links, which means that both links are simultaneously used and uses a high throughput load balancer. There's what we call as an active passive link, and an active passive link just means that one link is active while the other one is standing by. Now, let us look at some of the first hop redundancy protocols that have been there through the years. Let us start with the VRRP, which stands for Virtual Router Redundancy Protocol. It creates a master and a backup router. Has an advertisement interval 1 second saying that I'm there. In case it does not respond within 20 seconds, then the virtual router will just assume that this router is normal and it's going to take over the responsibility or the responsibility of doing the default gateway. The IP address of the virtual router could be the IP address of the router, the router that is going out, meaning that it's a virtual router created inside the router that you're using to go out, so that in case this a physical router fails, then the virtual router is going to take over. Another protocol that we have is the HSRP, which is Cisco proprietary, meaning that it is owned by Cisco, which stands for Hot Standby Redundancy Protocol. It's an active passive link. We have what we call as the GLBP, that is the Gateway Load Balancing Protocol. It's an active link, meaning that all links are simultaneously used. We have what we call as the Huawei Redundancy Protocol. It's Huawei proprietary. I believe it's active passive. And VGMP, which stands for Virtual Group Management Protocol. So these protocols are going to change according to the vendor that you're going to meet. It could be Cisco, it could be Huawei, it could be Juniper, but they change. The one first hop redundancy protocol that is a industry standard is VRRP, which is the Virtual Router Redundancy Protocol, and it's used all over the networking vendors' devices. So the HSRP, HRP, VGMP are going to change according to your vendor, your networking vendor. Now, we have looked at different change management procedures. We have looked at safety procedures. Let us now look at how we can recover data instead of in case of a disaster, and this is what we call as disaster recovery. And what I mean by disaster recovery is the ability to have a group of servers or networks or machines that are up and running if a disaster occurs. Okay, which means that you're able to recover your network status even after a disaster has occurred. Now, one of the strategies that we could use is backup. I talked about RAID in a separate video. I'll make sure to link it in the description. But we are not going to talk about RAID this time around. We're going to talk about the different types of backups that we could have. There's what we call as a full backup, which backs up all data in that specific system. There's what we call as differential backup, and it backs up data. Differential backup backs up data since the last full backup, and it's going to be slow in case of a restoration because you have to do a full backup, then you do the differential backup. There is what we call as an incremental backup. This backs up changes since the last full, differential, or incremental backup, and it's going to be slowest in case of a recovery since you have to do a full backup, a differential backup, which will be several of them, and several incremental backups. So backup is one of the strategies that we could use whenever we are doing disaster recovery. Another thing that we could do, but this is mostly common in virtual machines, is taking a snapshot of that specific system. This backs up the entire server, including the state information, what state it was in, whatever files were contained, whatever processes were running. That is all included in a snapshot. And I have said earlier, this is mostly in virtual environments, especially when you're working with a VirtualBox. That is for Windows users. Now, another thing that we could do in case of or in preparation for disaster recovery is having alternate sites. We talked about cold ISOs and hot ISOs. This time around we're going to be talking about cold sites, warm sites, and warm sites. Cold sites, warm sites, and hot sites. And what we basically mean by this is having different buildings with different heating, ventilating, and air conditioning systems, floor space, and hardware. This is what you are going to consider. So a cold site is a separate building with power, HVAC systems, that is the heating, ventilating, air conditioning systems, floor space, but we have no server hardware. So it's basically a building with all these air conditioning systems, with power, but you don't have server hardware in that specific building. That is what we call as a cold site. So it's easily to move in, but you need, so it's easy to move in, but you need to deploy the server hardware. There's what we call as warm sites. Warm sites are separate buildings with power, HVAC systems, floor space, and server hardware, but it is not up and running. Okay, so it's whenever you have failure, you can transfer to this specific warm site and just have the servers up and running. That way you're able to recover from the disaster. There's what we call as hot sites, and this is basically a separate building with power, HVAC systems, floor space, server hardware, and synchronized data. That means it's up and running and it's synchronized to other sites that you may be having in your company or your organization, say so. So alternate sites are a very good option when it comes to disaster recovery. Now let us look at some of the standards, procedures, and rules that you need to follow when it comes to networks. Now some of these are documents that you will find as a network engineer or as a system administrator, either when deploying or maintaining network equipment or networking equipment. The first procedure or rule that we're going to look at is the service level agreement, that is SLA. Now, a service level agreement is the promise that you make to your users about how long a system will be down in case of a disaster. Okay, a recovery time objective is the maximum amount of time a system will be offline in case of a disaster. You need to understand these terms. There's what we call as the RPO, that is the recovery point objective, and refers to the maximum amount of data that can be lost due to a disaster. There's what we call as mean time before failure, and this is the average amount of time before product failure. There's also what we call as the mean time to repair. Is the average amount of time required to recover a failed product or to revive a failed product or a network. There's what we call as a privileged user agreement, and this is a policy that states what privileged users are available, and for specific users or groups, it just states whatever privileged users you have and in which group do they belong in your system. Okay, you could have an admin in the finance section, an admin in the HR, an admin in the accounting section. So all these privileged users must be noted somewhere in a privileged user agreement. We have what we call as a password policy, and this dictates the minimum requirements for passwords, that is length, a mix of upper and lower cases, that is alphanumeric characters, special characters, emojis, all that stuff. There's what we call as onboarding and offboarding procedures, and these are the guidelines for adding user accounts to new hires and removing user accounts for employees leaving a company. So whenever an employee joins your network, there are those procedures that they're supposed to follow to get a new account, and when they are leaving that specific company, there are procedures they're supposed to follow to ensure that the account is deleted and is no longer a function. There's what we call as the licensing restrictions. This specifies allowable usage for an application. That is, for example, installation of one server for only one device, or a certain software for a certain period of time. Okay, there are those people who pay for software yearly, so licensing restrictions will fall under that. International export controls. This defines the restrictions on exporting certain software to other countries. For example, you are aware that Huawei is banned in the US and Britain, so you cannot use Huawei products in US and Britain. So those are some of the things that one needs to be aware of. Ensure that you're able to understand what software you can use in your specific country and what software you cannot use in a specific country. Another thing you need to look at is the data loss prevention, and these are policy intended to prevent a company's sensitive information, that could be financial data or employee social security numbers, from being leaked outside a company. Okay, so data loss prevention is very important when it comes to user accounts and company networks. Okay, there's what we call as the incident response policies, and this defines what constitutes an incident and presents a detailed list of steps to be taken after a defined incident occurs. Say for example, a fire has occurred. What do you do? This an incident response policy will take care of that. Say for example, you have been hacked. What are the procedures that you need to take? Okay, so the incident response policies are going to have the detailed incident and the steps that you need to take after the incident has occurred. There's what we call as the BYOD policy. There's the bring your own device policy, and it identifies what employee owned devices can use or how employee owned devices can be used on a corporate network, along with the level of support given to such devices. You could say that you could use an employee in your company could bring in their laptop, but their laptop can only be used for certain tasks and not certain tasks. So a bring your own device policy clearly states what is the acceptable use policy of certain devices, of employee owned devices. Now I've talked about acceptable use policy, and this is what defines how employees are supposed, or what employees are allowed to do with corporate resources. Okay, an acceptable use policy. So if an employee in your company comes into a certain use cases, they're supposed to know, I can do this, I cannot do this, I can do this, I cannot do this. So that is what we call as an acceptable user policy. There's what we call as the NDA, that is the non-disclosure agreement, and these are legally binding documents between a company and an employee, where the employee agrees to keep a specific information confidential. So there's some information about your company that you're not supposed to be going yapping about. So an NDA will make sure that all this is taken care of. There's what we call as the system life cycle, and this describes the different phases of a piece of hardware in existence in your data center or in your network operation center. Okay, when a device is brought in, or in case you buy a new router, what are the procedures that follow until that router is no longer usable in that specific network? You could say you bring it in, make sure you take the IMEI, you change the defaults, make sure you deploy firewalls, all that stuff. The system life cycle is supposed to define the different phases of a piece of hardware in existence in your data center or in your resources or in your corporate resources. There is what we call as safety procedures and policies. We looked at some of them. That is power safety. We looked at lifting safety, and what else did we look at? Just a little fire safety. We talked about fire safety. So safety procedures are guidelines that for conduct which helps maintain a safe working environment. Okay, so safety procedures and policies is a must to maintain when it comes to network operation centers. Okay, now let us look at wireless for a little bit, or for a while. In case you are hired to go and deploy wireless networks in a certain area or in a certain building, then there's what we call as a site survey. There's what we call as a site survey, and this survey is whatever survey you carry out to ensure that whenever you're deploying your network, you're able to cover the whole area of that building without leaving certain parts uncovered. And this will mostly happen with the wireless networks. So if you're doing a site survey for a wireless network deployment, you need to use an application to measure the radio frequency to ensure that the site is completely covered. So make sure you scan for the radio frequency of that specific area and ensure that the whole area is covered. Now, a trick to make sure that you're not experiencing slow speeds, since radio frequency is used by a lot of technologies out here. Okay, there's FM using the same, there's Bluetooth using the same frequency. There's a lot of technical stuff when it comes to radio frequency. So a trick to ensure that you're not having slow speeds in your network, you need to change the band or the channel that you're using. For those who are using the 2.4 gigahertz, and this is used for Bluetooth and other devices, so you need to change the channel from either 1 to, you can use 6 or 11. Same for the 5 gigahertz band. These are channels that will not have a lot of traffic traveling through them. So if you use these 1, 6 and 11 channels, then the possibility of having a higher internet speeds is guaranteed. Okay, so thank you for joining me in this very exciting and very educative video. I hope you have learned something. If you haven't subscribed already, kindly make sure you do. And if you have any critics or questions, make sure you post them in the comment section below, and I'll be ready to answer to them. So thank you for joining me in this one, and see you in the next video. Peace.